Hello everyone, my name is Emma Svatos and I am a wildlife ecology apprentice at the Wilds in Cumberland, Ohio. Thank you for tuning into my poster presentation. Today I will be sharing some preliminary research that I have conducted here at the Wilds. I have investigated the use of acoustic monitoring as a technique to understand songbird community composition in areas of varying forest restoration. I intend to use the insight I gathered from this project to guide my methods and analysis of future research into songbird response to forest restoration. So traditionally, bird surveys are conducted by going out in the field and manually listening and identifying birds. However, to a non-expert like me, this can be, challenging and requires many outings into the field. Fortunately, autonomous recording units, also known as ARUs, are becoming an increasingly common way to conduct surveys of avian population. An ARU is essentially a microphone that records bird vocalizations in a given area and stores the recordings for future playback. Using ARUs gives surveyors more options as they're able to, replay calls multiple times, save the calls permanently, and overall it requires less field outings. Conducting acoustic surveys are important for the management of songbirds as they can be used to help monitor populations, identify forest indicator species, and observe community composition in an area. Acoustic surveys can also be used as a way to monitor forest restoration efforts, since the birds present in an area is dependent on the resources available in the area. So here at the Wilds property, we have over 10,000 acres of reclaimed coal mining land that today is considered low quality habitat. Where the mining once occurred, the soil has poor nutrients and is compacted, and overall the forest is overgrown with invasive species as seen here. From spring 2017 to spring 2019, a 30-acre forest restoration project took place on the property called Healthy Forest, Healthy Wildlife. Restoration efforts included removal of invasive species, planting native trees and understory, and the construction of a vernal pool, shown here in the after. Since February 2019, acoustic data has been recorded at this restoration site using ARUs in order to monitor bird and amphibians at the site. So the goals for this project was to use this audio data collected by the ARUs to determine what songbird species are present at the restoration site, and compare the community composition to two reference sites of different forest restoration. By comparing the songbird community at the restoration site to these other sites, I hope to better understand communities at varying levels of forest restoration, and gain insight into how the restoration efforts taken place here have altered what kind of birds are able to use the habitat. So looking at my study sites, I have my restored forest site here in green. I also have showing the two comparison sites that I also recorded audio from, which are a remnant forest here in blue and a non-restored forest here in orange. So the remnant forest site was never mined. However, the non-restored forest was previously mined, similar to the restored forest. However, the non-restored forest has had no restoration efforts experienced on it whatsoever. I recorded the 2 weeks of audio at each site this past November and December. To record my audio data, I used ARUs that were set to record 5 minutes of audio every hour at the top of the hour, 24 hours a day for 2 weeks. Between the three sites, I had over 100 hours of audio recordings. I used a software called Kaleidoscope Pro, made by Wildlife Acoustics, to cluster my audio data, which essentially means that the software lumps similar sounds together and makes the process much more efficient. Once the data was clustered, I was able to identify bird species by sound. For example, this is what the spectrogram of a Carolina wren looks like, and this is what it sounds like. I analyzed my data by looking at species richness and community similarity. However, due to a lack of repeated sampling at the sites, I was unable to make statistically significant statements on my findings. However, the goal of this project was to identify trends in the data to help guide future research in this area, which the results of this project did accomplish. So first, looking at species richness, I identified 24 different songbird and woodpecker species across the three sites. As you can see, the species richness at the restored site was more similar to the remnant site than the non-restored site. The restored site also had fewer unique species when compared to the remnant site than when compared to the non-restored site. This was also true whether or not woodpeckers were factored in. Moving on to community similarity, I use the two most commonly used similarity measures, which are the Sorensen's and the Jacquard's similarity indices. These indices result in a similarity coefficient on a scale of 0 to 1, with a value of 1 indicating that two communities are completely identical. I found that the restored forest songbird community was more similar to the remnant forest than the non-restored forest, using both the Sorensen and the Jacquard's indices, as well as whether or not the woodpeckers were factored in. Overall, I found that the ARUs were an effective and efficient tool to conduct acoustic surveys and gain information regarding songbird species in an area. However, a major limitation to my acoustic surveying was that I could only record whether or not a species was present, but I could not make an accurate assumption about the number of individuals present. This limited my analysis options, especially without repeated sampling. That being said, the trends among species richness and similarity indices suggest that the songbird community composition of the restored forest may be more similar to the remnant forest than the non-restored forest. This would mean that the Healthy Forest, Healthy Wildlife restoration efforts effectively changed the habitat enough for different species of bird to be present than before the restoration. Using the knowledge gained from this project, I intend to use long-term acoustic data previously recorded at the restoration site, as well as use repeated sampling, to investigate the change in songbird community composition over time following forest restoration. ARUs overall are a promising tool to monitor songbird communities and evaluate forest restoration success. I would like to quickly say thank you to the great people at the Wilds for providing the opportunity and resources necessary for this project. And I would also like to say a big thank you to you, the listener, for listening to my presentation. Have a good one. Thank you.